Welcome to another video of Blue Tech Empire Python tutorials. So in this video, we are going to be looking at the data type tuple. So I would just like to put in here the data type tuple is similar to the data type list. So most of what we'll be doing on tuples are things we already did with lists. So if you want to know more about tuples, I would like you to like watch the video on lists. Try to watch the video on lists before getting into this video. If you haven't watched the video of lists or you don't know how lists operate in Python, I would like you to watch the video on lists so that you can easily follow up on this video. So let's move right straight to the video. As you can see, tuples are like lists in that they're also sequences. They can contain multiple data types within them, a list of items, and they are also iterables. It means you can iterate through them and you can carry out the index operator, the slice operator, and even concatenation operator, and you can carry out the repetition operator. We're going to be looking at all these different things you can do with lists that makes them similar to with tuples that makes them similar to lists. So let's go straight into the content of today. So let's create some tuples called, let's say, T1 equal to, take note, with lists, you have square brackets. With tuples, we use parentheses. So let's say 2, 3.5, let's say 4, let's say 5 plus 2j, 5 plus 2j, let's say 1. You see, here is now another tuple within this tuple. 1, 2, let's say 3, 4. Here is a list. And let's just have a boolean false, and maybe let's end it with a set. Let's end it with a set which has the value 2, and or let's say 4, and has the value true within it. So we have created a complex tuple, not really a complex tuple, but a tuple with multiple items, all of different data types. So let's create a list too with similar data types so we can be using them interchangeably. Now let's see tuple 1. As you can see, tuple 1 contains an integer. It also contains a float, it contains a string, it contains a complex, it contains a tuple, or another tuple. That's, it has a list, it has a boolean, and it has a set. We're gonna look at the set data type later on. So now, what are the stuffs you can do with tuples? Like we said, tuples are similar to lists, so you can access their indexes. For example, if you say T10, it's going to give you the first item. Like I explained in the value on list, iterables, Python starts counting from 0. So the first item is 0. We have 1, 2, 3, 4, 5, 6, 7. We have 7 items because remember, this is just one item. We have 7 items in the list, and we can prove that by using the inbuilt method len T1. And we have, all right, we have 8 items in the list. 1, 2, 3, 4, 5, 6, 7, 8. But like indices starts from 0. So we have 0 in this, 1 index, 2 index, 3, 4, 5, 6, and we have up to 7 indices. So if you're using the index operator, that's this square bracket, to access or to get items in the tuple, you have to know you earn 1 digit less than the length of the list. So for example, if you want to access the last item, you're going to be saying 8 minus 1, which is 7, and it's going to be 7, you see. And we have the last item, which is the set true tall. So you can also access any other item within it. 3, you can access the fifth item or the sixth item. 3, 4, 0, 1, 2, 3, 4, 5, 3, 4. So you can use here we are using the index operator to access different items within the tuple. And like I said, you can also use negative indices, like I told you. In Python, iterables, the last item usually has index 1, like for strings and lists. Here, this item here at the end is at index 1, negative 1, sorry. This one is at index negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, right up to negative 8. Luckily for us, when using negative numbers, it matches the length of the iterable. For example, the length of this T1 is 8, and we also have a negative 8 index, which is the first item. Unlike when you're using positive, which starts from 0, so you only have an index 8 minus 1, which is 7. You can't have an index 8. In fact, if you try it, Python is going to complain bitterly. So Python tells us we are tuple index out of range, but we can say negative 8 because it actually starts from negative 1 from the back. So we can reach right up to negative 8, which is 2. Now, that's how we use negative indices. You can use any form. You can say negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So let's get negative 6. It should get us 4. So here are the stuffs you can see with tuples using negative indices. So let's say you don't want to use negative indices, but you want to access the last item. It's simple. We know it's 8 minus 1, and 8 is the length of the tuple, which is T1 minus 1. So it still give us the last item, or you can say 8 minus 1, but usually if the list is too long, you might not be able to calculate it, so you want the len function to do it for you. Now let's look at the slice operator. The slice operator, let's print T1 here. Now the slice operator is used to slice or collect a portion of an iterable from another iterable. For example, we may want to create a tuple list, tuple 2, that has items from say 0 to 4. We are going to slice through tuple 1, collect from 0 right up to 1, 2, 3, because we know the last item is not going to be included. So here is how you do it. You use what is called the slice operator. We learned a lot about the slice operator on our video on strings. So if you want to understand this very well, you can watch the video on strings, or you can watch the video on lists. So slicing is very simple. You just need to use what we call the slice operator. You apply the first index, you specify the n. In this case, remember, the n is not included in the sliced tuple. If you slice a list, you get back a list. If you slice through a tuple, you get back a tuple. So let's say tuple 2, because we know it's going to return a tuple, equals to, we use the slice operator. We start from the first index and we want this to be included. So we're going to end in an index upper than this, because the last index we specify will not be included because it's the stop index. The stop index tells Python stop here. It doesn't mean return this. It just means return this, return this, return this, and stop here. So 0, 1, 2, 3. So we can say 3, and Python is going to stop. Let's say T2. It stopped here and return this. What if we want to return this? We have to stop here. So we say 0, 1, 2, 3, 4. So we need to use 4. Yeah. There. Now let's check 2. All right. So Python actually stopped here. Now this is how you do it. You understand? You can move right up to your, let's say 0, 1, 2, 3, 4, 5, 6, 7, because we want to stop here. So let's specify 7. 7. All right, let's check T2. All right, so it got up to here. What if we want to move till the end? Can we say 0, 1, 2, 3, 4, 5, 6, 7? You see, the length 7 is the last index, but we want to include the length. So if we say 7, it's going to give us till here. So we have to say 7 plus 1. Even though 8 is not an index, when you're slicing through, you have to use 8 if you want, or you have to use the last index, or the last plus 1 index if you want it to be returned. So for example, let's see T2. You see it extracted from beginning right up to end. Another short form of this, in case the string is so long, let's say 3,000 items, and you don't even know because you collected it from a database which is dynamic in nature, you may just place len here, because you know the len of T2 will give you 8. So instead of writing this, you can just write len and press T1, and there you go, you still have the same stuff. But Python also tries to help you by allowing you to omit the last item. If you omit the last item or the ending index like this, Python knows you're talking about the end. Now look at T2, we have the end. Now if you want to extract, let's say from, not from the beginning, but let's say from 3 right up to the end, we're gonna do this. So it starts extracting from 3. As you can see, here is the third 0, 1, 2, start extracting from here right up to the end. What of if we don't want to extract right up to the end? We can start extracting from 3, maybe let's say to the 6th. Remember, the 6th will not be included, it's only going to be the 5th. So 0, 1, 2, 3, 4, 5. 5 is going to end here because we said 6, so 6 is the stop index. So let's see what happens. T2. All right, you saw it returned from here right up till here. All right, so that's perfect. Now what of if, let's say, we want to start we so it's very easy. Like you saw, if you want to move to the end, you can use this. If you want to move to a particular index, you can say maybe 7 and you get that index. Now what of if you want to move from the start? We can use 0, but Python allows us to leave it empty. If you leave this part empty, Python knows you're actually starting from the start. So it starts from the start and gets up to the 6th index and returns the value in the 6th index. 7 is the stop index, so it does not return the value at the 7th index. So I just want to show you, and you can even go as far as being so stubborn also, like in a hurry, and you can do this. If you do this, what most people will do, you're trying to tell Python, please just copy this stuff for me from beginning to end and assign what to the extract. So it's going to go all through like this, extracting everything right up to the end. And as you see here, it gets it right up to the end. Now let's check T2, it's to the end. Now that's a very simple way to do stuff with Python tuple. Now let's see some other stuff. Let's try to use what we call negative indices. First we're going to print our tuple. Let's see what our tuple still has. All right, so now, like I told you, the last indices is -1. We can even try that by saying T1 -1. You see it returns the last item. Good. Now, what of the first item? The first item is -8 or negative the length of T1, because the length of T1 is 8. So we can just say negative the length of T1. If the list is so long, you may not know the value. So you can just want to say you can use 0, so you may never ever apply this, but you can also say negative the length of T1. Now it's still 2. Now take note of this. You see, when you use negative indices, you're moving like backward. And also because it starts from -1, the length of the string is actually the first item. When you're moving forward, because you start from 0, the length of the last item is the length of that tuple or that iterable -1. Now let's see how we can slice through using negative indices. So for example, we want to create something, a tuple starting from the last item. Let's say we want to start from -1 right down to 4. You're going to say -1, -2, -3, -4, -5, -6, -7, because it's going to be -7. It's not going to reach the end. This is the stop. So it's going to extract to here. So let's say -1, 2, 3, 4, 5, 6, 7. Let's say -7. Let's see what happens. All right, T2. Oh, nothing was returned. Why? So Python, this index operator has a third parameters which we haven't been talking about. It's been hiding all through. So let's see that third parameter. The third parameter usually has a default value 1, which means a step of positive 1. That's why each time we actually created a list, for example, this is going to fail. But if we say something like this, yeah, so something like this, or let's say 0 through 7, it was automatically 1. That's why it moved from the first item. It has a step of 1, 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 till it reaches the stop index that we specified. So that step was hidden. Now in our case where we are trying to extract negative indices, the step still the steps. Why? Because take a look at T1. T1 ends with negative, it has a couple of items, but we started from -1. Now we try to move backward, but the problem is we had a step of +1. So from here, it tried to move forward. It was going and found no item. So it simply returned us an empty tuple. So now what we have to do in that case is look at what happens. Now, because our Python is trying to go ahead to look for the next item, we just need to put the step of -1, trying to tell Python, start from -1, move steps of -1 backward up to where you reach -7. So we're going to change this to -1, and we're going to have this. So as you can see, the result is truly it actually started from the last item, moved to this, and it stopped here. So it ended with this by returning. This was the last item it returned, because here was the stop index. Here is -7, so it wouldn't return the stop index item. So that's the way you can move backward. You can even move 2 steps backward by using -2. Remember, you can also move 2 steps forward. For example, in this case where we started from 0 to 7, we can say, or let's move from 0 to the end, and we can tell it to move 2 steps like this. T2 now. You see it moves from 2, skipped 1, 4, skipped 1, and where are we? Move 2, skip 1, 4, skip 1, yeah, 1, 2, skip 1, 4. So we can even tell it to skip 3. If you write it now, you're going to get 2. Skip every 3 items. So here, that last item is known as the step. It's like make a step of 3. So it goes from here 1, 2, 3, then 1, 2, 3, 4, 1. The list is ended. So it ends at false at the last item. So I just want to show you how that actually works. So you can also use negative indices like I've shown you, but you need to be careful. So if you want to use negative indices with a positive step, you need to start from a lower negative index. For example, you can start from here. Let's say 0. Let's check the T2. Let's check T1 so we can follow through. What? All right. So 0. So now let's move from -1, -2, -3, -4, -5. Let's take from -5 to to the n, or let's say -1. So it's going to pick from here to, it's going to, -1 is the stop index, so it's going to end here at false. Let's check this out. So T2. So you see here. Now if we want to take from -2 to the end, we're going to take like this. We're going to use this, yeah, and a step of 1. Now because it's a step of 1, it starts from the negative index and the most positive 1 spaces steps ahead. If you say -1 here, it's going to move negative steps backward, and it's going to return you something like this, because it started from here and then moved towards the end backward. Yeah, so that's a simple way of reversing a string. If you want to reverse a tuple, create another tuple which is a reverse of this tuple, you just need to tell it to start from -1, move to the end, and have steps of -1. That tuple 2 is actually the reverse of tuple 1. So I just wanted to show you how you can normally operate with tuples. So we have looked at the index operator. What I've done is actually a summary of what I did in the videos on lists, but as you can understand, we are actually doing those stuff with tuples. So let's look at some differences between list and tuple. Now we have L1. You have a list, or let's say let's create L1. Let L1 be equals to list. It looks like I made a mistake. I created 2 tuples. So all right, so L1 is now a list. Let's try type L1. a list, while we have T1 as a tuple. Take note, list starts with square brackets. I converted the tuple to a list. List starts with square brackets, tuple starts with curly bracket, and if you type, you see T1 is a tuple. So I just want you to take note of those stuffs. T1 is a tuple and L1 is a list. So now look at a few stuffs with list and tuple. Now let's consider the list first. Let's try to we can also reverse a list like we did. For example, if we have L2 equals to, we can do everything we just did with tuples. We can also do it with list. We can say it's equals to L1 equals to L1. Let's try to reverse this, starting from -1 index, moving to the start, then going -1 direction. If we check L2, we see the reverse of L1. So everything we did with tuple, we can do with list. So let's forget about that. Now, but the difference is we can try to, let's have L1 again. We can try to change the values of items in L1. Let's try that. L1 at index 0, 1, 2, 3 at 0, 1, 2. Let's try to change the value at index 2 to be equal to 5. And let's try to change the value at index 2 or let's print L1 to show what happened. L1. All right. See, um, we have 5 here now. Let's change this to something else. Let's change it to some other stuff. Let me say, let's put a data type. I don't want to use a dictionary. In fact, let us even change the last item. That last item, it looks too long. Let's change it to something like maybe like 3.22. Let's just change it. Then L1. Yeah, we have changed this. It's no longer the set root all. We've changed that. Let's change this. It's looking somehow here. I don't want it. Let's change 0, 1, 2, 3, 4. So let's change the item at the fourth index. It's not so good. 0, 1, 2, 3, 4. Let's change it to something like, I don't, let's just change it to some random stuff, maybe an integer 1000. Yeah. So now let's check this one. So we have changed a lot of stuff in this one. Now let's try that for the tuple. Let's first see our tuple. Let's try to change stuff in the tuple too. We don't like this. We change it to 5 in the list. Let's try to change it in the tuple. T1 0, 1, 2, 2 equal to, let's just use 5. I've been using 5. Oh, there's an error. Maybe we made an error. Let's try to change the last item in the tuple to something else. T1 -1. I think we should just change it to some random string float. We still had an error. So tuples are, unlike lists, are um immutable, which means you can't change their values. They are similar to strings in the fact that they are immutable. Once the objects are created in memory, the value of that object can't be modified. So remember this, tuples are immutable while lists are immutable. You can assign values to a tuple, and for example, look at our list. We can even let's replace the first 3 items with another item. We can say list 1 slice through 1, 2, and 3, and replace it with the item with equals to, replace it with something, replace it with even let's say 25.5. Sorry, we made a mistake. 0, 1 equals to L1, and can only assign an iterable. All right, sorry, there was a mistake. Equals to so let's see L1. So we have replaced the first item with, you now see L1 was 235. We have replaced the first 3 items with this. We sliced and replaced. With tuples, that's impossible. You can't change any stuff in a tuple. You can, for example, if you try to do that with T1, let's try to do that stuff we just did with L1. Let's try to do it with tuple 1. Impossible. Tuple does not support item assignment, so you can't change the value of a tuple in any way given. Once it's created, That's all. It's sealed to memory and we can't change it. So I just wanted you to know that that's one of the difference between list and tuple. You may be asking, what's the importance? Now, you can have some important data. For example, you may do a network connection and it returns you some socket of this form, maybe 192.168.0.1, and maybe it gives you the address and the port, maybe 4453, something like that, and you have this tuple. Now, this information is very important in network connection and you should not change it. Like, you may not be able to communicate with a remote server. You may have to recreate a new connection or reinitiate a new connection to the server. So tuples are used for data integrity. If you have a piece of data that you may pass to different modules, and maybe these modules may have some bugs, you may not know, but you want this data to remain constant. You don't want this data to change throughout the execution of your program. You will preferably put that data in a tuple, because if it's in a list, some part of your program may mistakenly change it without you knowing. So tuple are used to maintain data integrity in Python. Data integrity, like you want some piece of data to remain constant once it's been created. You don't want any addition, you don't want any subtraction. You just want the data to remain constant. It's very important, and a lot of modules will return data in tuples or ask for you to input data into them in tuples. So we are going to see a lot of examples on that, but I just want you to know tuples are important for the data integrity they provide. That's one alternative when it comes to lists. In most other stuff that you need to operate lists, expand them, shrink, all those kinds of things, you can do that with lists. But if you want some piece of data that should never change, nothing should be added to the data and nothing should be subtracted from the data, you preferably use a tuple, because tuples maintain data integrity. So I want you to know that. Now, you can also consider tuples as a read-only data type. You understand? Yes, they are read-only because once created, you can only read values from them. You can get items from different indices. You can obtain items from a tuple like you do with a list, but like you can read items, but you cannot place items in a tuple like assignment operators. So we say somehow they are read-only, they are not writable. Unlike lists are read-only and writable. So like we see here, we say tuples can be thought of as read-only lists. Below is an example. So we see some examples here. And we see a tuple here, we see another tuple, you see you can print tuple 1, tuple 2. Yes, it's going to just print tuple 1 separated by space tuple 2. Tuple 3 is equals to tuple 1. You see we can start from index 1, end at index 4, then steps of 1. Yeah, so it starts from, you see what it returns 3, starts from index 1, moves here, end at this index. So it returns just this index. So we have done all these tuple -2, the negative, the second two, but the last but one index, -2, 0, -1, -2, or from here, -1, -2, 3.5. And you can see more stuffs here. You can see tuple 1 start from the beginning, reach to the end, but steps of 2. You can see now we can concatenate tuples. For example, we can have something like tuple 3 equals to 2 g ree, comma 4 plus 5j, and we can have t4 equals to I, maybe have the dictionary, and maybe have the, sorry, we made a mistake with this tuple. We're supposed to end it with this. So let's see tuple 3 is what, and we can see tuple 4 gives us this. Now we can say a tuple 5 can be equals to tuple 3 plus tuple 4. Let's see tuple 5. So you see tuple 5 now is a combination of both tuple 3 and tuple 4. Remember, tuples are immutable, so it did not add the items of tuple 4 to tuple 3. It just created a new tuple which will contain items in this tuple and this tuple. So remember that it did not try to add items together. Just remember that it did not add more items to tuple 3. You see, so it just created a new tuple. So here is known as concatenation or appending, but it's more like concatenation. Now you can also use the repetition operator. For example, we can repeat tuple 4. We can create a tuple 6, which is a repetition of tuple 4 times 4, like this. So we can see tuple 6 gives us this. You see, it's tuple 4 times tuple 4, tuple 4, tuple 4. So it's four instances of tuple 4. So very nice. So you can use the addition operator, which is concatenation, to add two tuples together, and you can use the repetition operator like we did. But you can assign a value to a tuple because they're read only, like we have seen before. So I just wanted you to see that. And like we said, as you can see from the script, tuples are sequences. The index and slice operator works with the tuple the same way it does with other sequences like lists and strings. Also, notice that towards the end of the scripts, when I try to change the value of an item in one of the tuples, an error was generated saying object does not support assignment. This error is simply trying to tell us that we are reading from here that tuple objects are immutable and their value cannot be changed once created, like we have explained. As you can see from the code above, tuples can also contain objects of different type, like this. Our tuple contains a string, a dictionary, a float string, and in the other one we can have whatever. We even had a complex and so on. So above, so you can see, you may be wondering why tuples need um why why a tuple is needed when we have a list. There's already a list data type, so you can say why we need a tuple. So Python knows what it's doing, like I explained to you. Tuples are used to store data that should not be changed throughout the life of the program. You may write a code with some data that which needs to be processed by several modules, maybe some which are imported, to maintain integrity of a particular set of data such that it can be used but shouldn't be changed by any of these modules. You will preferably place the data within a tuple, which is read-only, rather than a list, which is read-write. So I just wanted you to understand that. So now let's see the last stuff with tuple. So now let's say you want to create a tuple with just one item. What are you going to do? You may think it's possible to write T1, for example, equals to, let's say, um, 4.5, and let's print T1. You see, it just prints 4.5. You may be wondering, so how will I create? So let's even check the type of T1. We see it's a float. Now, why? Because you can write something like this: 4.5 plus 1 times 3. Let's check T1. It's still a float. Now, why? Python considers parentheses as part of mathematical expressions. So you writing stuff like this can just be a mathematical expression. So Python doesn't know when you write something like this, whether you're trying to do some mathematics. Maybe you just put 4.5 in bracket, which is still equals to 4.5. So in order to create a one element tuple, you need to place a comma at the end like this. And Python knows, all right, this is a tuple. Now, if you print T1, it gives you 4.5 comma. If you print type T1, you see it's a tuple. You may be wondering, is this useful? Yes, sometimes some programs or modules require you to pass tuples as parameters, and this is what you like to do. You need to pass, if you have multiple, maybe it can take multiple items. So let's say it takes multiple items, and you want to pass multiple items to that parameter, but for the meantime, maybe you just have a single item. In that case, it will be a one item tuple. So you have to use a comma to make sure you're creating or you're passing a tuple when it's a single item. Now, one other stuff you need to know is, let us check the for tuples. Tuple, we see the different methods of a tuple. What we can take note of is count and index. Say for example, we have a tuple tuple 1, Let's count. Let's take tuple 1, or let's create a new tuple, sorry. Tuple 1 equals to, let's say tuple 1 equals to 1, 2, 5, 4, 1, 8, 1, 4, 5. So let's say 9. Now, we can use the count to count how many times a particular number exists in a tuple. For example, tuple 1 dot count 1. We said we have 3 1. We can say tuple 1 dot count, we can say 4. You see, it has two fours. And you can also find the index of a particular number. For example, let's find the first index of 5. You can say tuple 1 dot index 4. It's at position 3, 0, 1, 2, 3. Yeah. What of tuple 1 dot index 8? It's at position 5 here, 0, 1, 2, 3, 4, 5. What of tuple 1 dot 9? Dot index 9? Yeah, 9 is at index 10. Yeah, so perfectly we have found how to go about this. So I just wanted to show you this so you fully understand how tuples operate. So here is the end of this video on tuples. You have seen how to create tuples, how to index them, and how to carry out simple operation like slicing. But you have seen tuples are immutable and you can assign, change their values once they are created. In the next video we are going to look at Python dictionary. So see you then and have a nice time.